On today's episode, Tesla talks artificial intelligence and nuclear micro-reactors for the USAF. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. While nuclear fusion remains the long-range goal for the nuclear industry, several advanced fission technologies are not only practical, but they can be deployed in meaningful numbers fast enough to make a real impact in global fossil fuel use. While fission reactors are historically large civil engineering projects on the scale of conventional thermal power plants, a new generation of compact micro-reactors promises to make the technology portable and usable in locations where coal, gas, or diesel-powered generators are primary power sources. The U.S. Air Force has selected Eielson Air Force Base in Alaska as the location for the first small-scale reactor in military service in 5 decades. Early transportable reactor concepts were used in Greenland and in Antarctica, but they proved to be unreliable and more expensive to operate than conventional generators. New generation reactors operate with simpler, more reliable cycles than the conventional coolant loop systems used in traditional systems derived from naval reactor technology. Several competing designs are under development, some from startups such as Radiant Nuclear and others from industry heavyweights like Westinghouse. The key to small scale is intrinsically safe design, which simultaneously does away with the need for large and complex safety systems with multiple redundancy, and also does away with the heavy containment structure. Micro-reactors are generally sized to be truck transportable in shipping container formats with typical power outputs on the order of single-digit megawatt levels. Transportable reactor technology is naturally of interest to all the military services, and the Pentagon has started its own research program called Project Pele in 2020, with contracts issued to Westinghouse, BWXT Advanced Technologies, and X-Energy for design work. Workable designs are expected in 2022. With multiple companies vying to supply micro-reactors for military base use, the technology can reach a critical mass where it could be deployed in remote communities, mining and industrial sites, as well as used for emergency power and disaster areas. But U.S. military applications alone should have a significant impact. The U.S. Defense Department estimates power consumption at 30 terawatt-hours electricity per year and over 10 million gallons of liquid fuel per day. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. Artificial intelligence is on everyone's mind today, but a number of real-world applications to AI, well, they're surprisingly small. It's expensive, difficult to develop, and with current technology, it's reserved for the toughest computational problems, notably self-driving systems in the automotive industry. Now, Tesla has tackled the self-driving problem with a unique camera-only approach, which places very high demands on hardware and software to make sense of the environment around the vehicle to deliver error-free driving. Now, Tesla calls their system full self-driving, and it operates currently at SAE Level 2, although Level 4 or 5 driving has been anticipated for several years. To close that gap, Tesla has developed its own in-house supercomputer called Dojo, and in an unusual move has just published a technical paper on their in-house technology. Entitled Tesla Dojo Technology, a guide to Tesla's configurable floating point formats and arithmetic, the paper explains how Tesla has developed new formats and methods for 8-bit and 16-bit binary floating point arithmetic for deep learning neural network training. Why is this important? Well, the original standard, IEEE 754, dates to the mid-1980s and was designed to ensure identical results whether tasks were run in software, hardware, or a combination of both. This single precision standard was supplemented in a later revision with a newer, half-precision standard to address the fundamental problem of the original concept: very heavy demands on both processors and memory. By going their own way with an in-house standard, Tesla expects to decrease the hardware load even further, addressing a major issue in widespread implementation of self-driving: heavy computational loads that limit the ability of intelligent systems to process data and simulate in reasonable timeframes and at acceptable cost. Now, Alphabet's Google Brain AI unit they've been working on their problem with their own in-house solution, and Tesla may create a unifying standard, although without the expectation of full interoperability of code between platforms. So is this the AI equivalent of VHS versus beta? Well, given the relatively small number of supercomputer platforms in use worldwide, probably not. But as supercomputer costs drop and an increasing number of universities and research institutions adopt them, formats and standards begin to matter greatly, especially in a market where high-level coder talent is in very short supply. It's all about self-driving now, but it's clear that Tesla is developing AI systems capable of solving problems in other regimes. It's going to be interesting to watch. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.